So, what's that?
Okay, you know how you said you're going to have that little hint?
Yeah.
Little hint for the like I'm ready. You know what I mean?
What did I say?
Little hints. You have to rearrange.
Yeah.
Oh, yes. Oh, I'm so glad you said that. So already set up to cancel. Have to multiply by -1. Rearrange terms into standard. Okay, thank you for that. It reminded me. So rearrange terms into standard every time. Regardless of how messed up they are, you got to get them into standard form. Okay, so this is systems by multiplying. Okay. So where we just ended, that was one section. It was adding or subtracting. If you actually flip in your book, I know you don't have it, but if you did, the next section is 7-4, which is going to be multiplying first and then eliminating. So the high school who's doing this, with their 9th and 10th graders, you guys are the advanced kids, so we go faster. I'm doing it in one. This is one learning target. They're separating it into 2. So, but I think since we're kind of on this, you should be able to go with it. So, okay, so are you ready for this? Level 4 starts out with 6x plus 5y equals 19, and 2x plus 3y equals 5. So as I look at it, I don't see that they're both ready to, either one are ready to cancel. And in addition to that, I don't see that either of the coefficients are even the same. Like at least in the other one, they both were 3y's, right? I just had to multiply by a negative. I got a 6 and a 2, a 5 and a 3. So using that same concept of multiplying by -1, is there a variable, either the x's or the y's, that look like they might be easier to get rid of? Which one? You'll see it. If this 2x were a -6, would it cancel with this +6? So what can I do to get that 2x to turn into a -6x? Yes, multiply it, say it get louder, yeah. By -3, right? So here's the key, you got to do the whole equation by the -3. Okay? And somebody said you can just change the equation like that. So let's do a little sidebar real quick. We all know that you could take that fraction in half. Okay? Somebody give me their favorite number. What's your favorite number? 27? Okay. So 1 times 27 is 27, and 2 times 27 is 54. Aren't those still the same amount? Don't they represent the same amount? Here you have two pieces, and they have one of it. If you have 54 pieces, you have 27 of them. It's the same amount. So multiplying a whole equation, what does that mean? Do you think it's the same line on a graph or different? It's the same line. It's just 2x plus 3y equals 5. Multiplying this by a... Okay, now here's my question. Why not just multiply it by a +3? If I multiply it by a +3, I would get what? Just a +6x, and I don't want that. I want it to cancel. So watch what we're going to do. We're going to create a whole new equation. You got to do them all. Okay? So I got a -6x, a -9y, and then my -15. So this equation I don't really need. You can cross it off just so that you don't go to combine it, because sometimes people will go to combine these two. So now, is it ready to go? Is it a level 1? Yes. So go ahead and cancel out your x's, and then your y's are going to give you -4y, right? 19 plus -15 is 4. And y is -1. And now that I know that y is -1, I'll do just one real quick. Can I use any equation? Yes. And you know what? I actually this time, I'm going to choose to use this equation that I crossed off. Because why deal with bigger numbers than you need to? This is bigger and it has negatives. I'm using this equation. So I'm going to put that -1 right there. I could also put it here or here. So I'm going to ignore this, and I'm going to say 2x plus 3 times y equals 5. I will tell you a big mistake people will make. Your eyes are going back and forth from this spot to this spot often, right? So a lot of times kids will do the 2x and write it, the 3y and write it, and then they'll go back up and they'll look and they'll put equals 19 or equals -15. They're making like a hybrid equation. Do you know what that means? They're taking part of this and part of this, and it doesn't work that way. So I would definitely keep your finger on where you're writing so that you know, oh, use the 5, not the 19 or the 15. Okay? There's your -1. 2x minus 3 equals 5. Plus 3, so that your x is going to be 4. 8. Okay? Are we okay with this? Yeah.
And when you get added the two equations, where did you get -4y equals 4?
Because the 5 y's, because the y's, you had a positive 5 and a -9. So I added those two, and that gave me -4. And then a 19 and a -15 gave me 4. Got it?
Yeah.
Okay. So then that's where that. Okay, is everybody okay with this one? All right. So that's what a level 4 is. So if I were to ask you, we may not work these through all the way. I might just say to you, 4x minus 3y equals 15. 2x minus 3y equals 9. So I might just ask you, what are you going to multiply by which equation? You have two options here. Two pretty good options, right? If you want the y's to cancel, I would need to do what? They're pretty darn close. I just need one of those 3's to be positive. So I would multiply one of the two equations by -1, right? Good with that? Okay. What if I didn't want the y's to cancel? What if I wanted the x's to cancel? What would you do? Which one? Yep. Then this 2 goes into 4, right? So if I multiply this equation by a -2, then that term would be a -4 and it would be okay to go. Do you understand that? So I'm not going to do them all, but -4x plus 6y equals -18, and then it's good to go. Okay? So are we all right with that? So then I'm not going to finish it because I have a couple more problems that I need to show you because we need to get to a level 5. Are you ready for this? All right. A level 5 looks like this. I really, really want you to be able to figure out what to do. I'll be so happy if you do. -3x plus 2y. It looks like a big old mess of nothing, right? None of the coefficients are the same. The signs are the same for the y's. 3, I can't just multiply something by 3 to make it 4, unless it's a big decimal, and I don't want to deal with that. I can't just multiply 2 by something to get 5. So what are my options right now? Think about this. Is there a rule against multiplying both equations by something? No. So, yes, I'm hearing that. Oh. What if I want the x's to cancel? If one was a positive 12 and one was a negative 12, would they cancel? Yeah. So what would I multiply, JC, by right here to get it to be that?
You would multiply the 4x, well, everything by -3. And then, no.
Well, you could do it. That -3 would be okay as long as you, because it's going to depend on what he says here.
Multiply that by -4.
Okay. Yes. Okay. Or here's the hint. Are the signs already okay how they are? Like one's a positive, one's a negative. I'm not going to mess with it. I'm going to multiply this by a 3 and this by a 4. Okay? He said multiply this by a negative 3 to make this negative. Multiply this by a negative 4 to make this positive. That'll work too, but it's not necessary. But yes, you had the right idea. Okay, so do you see what I did? So now I'll have, and I will just distribute it through. You're going to have a 12x plus 15y equals 105. A negative 12x plus 8y equals negative 36. And now I don't need those equations. However, I'm going to keep them there because when I go back and substitute to get my second value, I'm using one of these. I'm not using these. Okay? Are you okay with that? I don't want to keep finishing the problem. I want to keep getting you some more examples. So, let's do it the other way. Let's take 4x plus 5y equals 35. And negative 3x plus 2y equals negative 9. And let's say you want to cancel out the y's. So I need you to understand that this literally can happen. Like if you work with partner and you decide to cancel out the x's and they decide to cancel out the y's, your work is going to look very different, but your answers will and should be the same. So what would I need to multiply both of them by to cancel out the y's? Be careful because the y's have the same sign. So what would I multiply this top one by? Anybody? Mm-hmm. Negative 2. Then this one has to be what? Positive 5. Right? Like you have to be able to visualize. Because this is going to give you a negative 10 and this is going to give you a positive 10. So do you see why over here they were both positive? But here one was negative and one was positive? Okay? So watch what that will give you. That will give you negative 8x, your negative 10y, and your negative 70, and your negative 15x, your positive 10y, and a negative 45. And then you go from there. Right? You're good with that? So negative 23x equals, and then go up from there. Okay, because I have to show you one more thing. Yes. Okay. Good, good, good. How about this one? Okay, because I want to show you that you don't always have to just multiply one by the other. So I know that you could either multiply this one by 5 and this one by negative 7, right? To make it a negative 35 and a positive 35. But do I need to go all the way up to 24? Yeah, it's like a GCF, right? Okay? Or LCM, rather. So least common multiple of 6 and 4 is 12. So I don't need to go all the way up to 24. So what would I need to do to multiply? Could you do times 4 and 6? Yeah. But if I want those to be 12, what would I multiply the first one by? Be careful, the signs are the same. One of them is going to have to change. This first one could be negative 2. That's going to give me a positive 12. Just 3. Are you getting it? Okay. So for these, it's all about just setting it up. Okay. Let's say 5. Okay. So then we would go through negative 14x plus 12y equals positive 2. 15x minus 12y equals 3. I'll just finish this one. I haven't done it in a while. So 15x plus a negative 14x is x. Remember, you add the columns. And 2 plus 3 is 5. So once the cancellations take place, you get this, and then you solve. So now that x is 5, you go back and pick one of them. Guess what? I'm not going to pick one of these. I'm going to pick one of the originals. And I have 2 more to show you, and then we got to get moving. All right, ready for this one. These are called special cases because we know that you can have lines that never intersect, and we know that you can have lines that intersect everywhere. Okay? So 2x equals 3y minus 8, and negative 2x plus 3y equals negative 5. So, first of all, something's off. It's not in the form we need it to be. So let's just do a quick little plus 3y, right? Yes. So when I do that, I'm going to have a 2x here. I'm sorry, we're going to subtract. A minus 3y equals that. Okay. What the heck happens here? You know something kooky is up. Because not only do the x's cancel, the y's also cancel. Which means you have nothing on the left and what on the right? A negative 13. Is that true? It's false. What does a false statement mean? No solution. I just need you to be prepared for this. So what about this example? Negative 8x plus 2y equals 7. Positive 8x minus 2y equals negative 7. Everything cancels. 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 So 0 equals 0. Is that true? Yes. What does it mean for a true statement? Infinitely many solutions. In other words, that means they're the same line. They're the same line. Got it?